All right, everyone. So as we look at chapter 10, you should have the blank notes in front of you. If you don't have those, they will be up on MrMathWell.com if you want to look for a reprint there. I'll also have these display notes up there too, in case you need to fill out your blanks on your own at home. You can look up that document. It'll look just like the one that's up here. Okay. So yeah, on page 308 in your textbook is where we start here with our notes. So if you want to follow along there, you'll see charts and different things that I won't be able to show you on the screen too. So, all right, so water quality and environmental health is what we're studying in the final chapter in the textbook here, chapter 10. And so let's start off by talking about some of the water here. Water is the key to life on Earth, and the majority of the Earth's water, that is about 97.6% of it, is salt water in the oceans and seas. The remaining 2.4% is fresh water. Okay, so as you see by this graphic here, most of the water on the Earth is in the seas, the oceans, and salt water. Water we can't we can't really drink that. You can drink it, but it's not good for your body, and yeah, it makes you sick. So there is a way of converting some salt water to fresh water, which we'll maybe talk about, but on a large scale, it's not happening right now. So we have a relatively small amount of fresh water that we're available to use. So most of the fresh water that exists on the Earth is locked up in glaciers, so big ice blocks on the North and South Pole. That's where most of the fresh water is. So it's not available for us to drink it or to use it really by most living things. So you see in this graphic again the world water distribution: 98% salt water, about 2% fresh water, and of that, only about 13% is so 13% of little over 2% is what we have available to us. So it's important to talk about conservation and purification of water and being responsible with that. Okay. Most organisms contain over 50% liquid water by weight. This water fills cells at the very cellular level and supports their structure. So to keep a cell as an actual three-dimensional, blob, let's say, there's water in there. It also provides a medium in which life-sustaining chemical reactions can take place. So a medium meaning just a kind of a place for that to happen. A mechanism, where the mechanism takes place in water a lot of times. And most importantly, one of the important functions of water in a body is to regulate body temperature. So water is a very, very important role in how we live, and even down to the cellular level there. Okay, moving on. Many things we need to live would disappear without water. Now, this is very interesting on how much water is really necessary for us to sustain how we live. I'm just going to shrink this a little bit. It's a bit big. So, food. Okay, obviously in food, plants and animals we eat need water to grow. So if you think about how water is important for our food, we wouldn't have food if the things we eat weren't able to use water. So to grow, to thrive, and produce, the plants and animals that we eat need water. It takes about, this is interesting too, about 40 liters of water to make one slice of bread. So if you think about the flour, which comes from the wheat, which is required to grow, the different processes and things like that along to make one slice of bread is about 40 liters of water. 200 liters of water to produce one egg. Okay, when you consider the transportation, when you consider going back to feeding the chicken and all that sort of stuff. And 3,500 liters to produce 1 kilogram of chicken to eat. So that's just some numbers for you. This little graphic that I have here is, it's cleverly titled, How Thirsty is Our Food? To produce 1 kilogram of different things, this is how many liters of water are required. And again, you think about the whole process. Okay, process of growing the plant or animal, of processing, of transportation even. I think all of it is wrapped up in that. This one, I don't know if transportation is in there, but this is average. So a kilogram of bovine meat, that's cattle meat, that's beef. Okay, bovine is cattle. So a kilogram of beef requires over 15,000 liters of water. If you consider the lifetime of a cow and different things like that. Even nuts. This is crazy. Nuts. You wouldn't think of lots of water required to grow nuts. That kind of thing. They're pretty dry, right? When you eat a nut, it's pretty dry. So you think, oh, there's no water in there. That can't take much. Look down at the bottom end, though. Vegetables. A lot of vegetables are like 99% water. Like if you eat cucumbers and apples and things like that, it's so much water. But it's one of the easiest to grow compared to some other things as far as water consumption. So kind of cool. Any questions about that? Okay, you can find lots of this data online, but I thought that was kind of interesting to talk about. Okay, so number 2, one was food, 2 is shelter and energy. So the wood used to build homes requires water to grow. Makes sense, eh? You cut down trees to build your home, the trees need water to grow. The production of steel, of cement, of other building materials, and most fuels to heat homes use some water in their production process. Hydroelectricity tops the list. Okay, so if you think about the electricity that's created to make this, the manufacturing process, the electricity that comes from dams and the movement of water is a huge part of that. So you think about, and even cement, like if you've ever poured cement or worked with cement, you got to add a lot of water to that compound to make it into the flowing sort of liquidy cement that hardens up. Anybody ever worked with cement? Yeah, I saw some nods. Okay, yeah, okay, that's good. Okay, so what's number 3 then? Moving on, number 3, health and hygiene. I'm sure you've thought lots about health and hygiene, but we need water to clean our food, our clothes, and even ourselves. So health, hygiene, human waste removal. So you flush things down the toilet. Also relies heavily on water. Water is important in producing pharmaceutical and plant-based medications as well. So I've got a picture of a washing machine here, obviously, to keep our clothes clean, to shower ourselves and things like that requires water. Even to clean our food. Yeah, and even our medications heavily requires water, if you think about that. Number 4, manufacturing. Most products we use require water at some stage of the manufacturing process. Thousands of liters of water are required to make a single pair of jeans. We talked about this the other day, I think. And hundreds of thousands of liters to produce one car. When items are recycled, recycling is a good thing to do, right? But recycling uses water. So when items are recycled, it takes more water to break them down for reuse. And if we there's benefits of everything, but there's also costs to things, right? Whether it's money or whether it's energy or whether it's water or different things. So we're going to watch a short video here now. You'll see this up on the website if you want to watch this. Okay. Number 5, transportation. It takes water to make cars and to drive them. Also, tankers, big oil tankers like pictured here, transport much of the oil used in motor vehicles. So if you don't know much about cars, there's a very important substance that is in every engine, the liquid oil that's in the engine that helps the parts to, helps the friction of the parts of the engine so they don't, overheat and wear down. It also helps regulate the temperature and lubrication and things like that. So oil is, you can't run your engine without oil. So if you have an oil leak, your engine is running, it just seizes up and stops. It grinds to a halt. So oil is very important in every internal combustion engine. And you don't think about the water that's required to even move the oil from one place to the other. Canada is a very oil-rich company, although right now we don't have the pipelines and the access to a lot of the oil that's under Canada. But a lot of parts of the world have to import their oil across oceans and stuff like that. So oil tankers require water. You don't even think about that kind of stuff. Recreation and beauty.
Mr. Wade Robertson.
A dip in a swimming pool, a camping trip, a game of hockey, a ski vacation, all require water. Even enjoyment of gardens and tree-lined streets would not be possible without water. Okay, so here's the beautiful garden that needs water to grow, and the lake that this person is skating on, playing hockey. That looks like a lot of fun to me, actually. That looks like a dream right there. Actually, long before you were born, there was one winter where we had no snow until well after Christmas. And I remember when I came home, I was playing hockey abroad, and when I came home that Christmas, I took my skates and stick out to the lake near our house, and it was just like this. It was me and a buddy. We were playing hockey, and literally there was no snow anywhere. It was like the biggest hockey rink you ever saw, and literally my buddy went like a quarter of a mile away from me. I could barely see him, and we would just like slap shot pucks to each other like the longest game of pass ever. It was so awesome. We just like unload this thing and just pass to each other, and yeah, that was good times. I was like 1996 or something, 94, 95, 96 maybe. Anyways, it's awesome. All right, but I digress. Well, let's keep moving on. Types of water pollution. So we've talked about waste and pollution in this class a lot. Let's talk about water pollution. Water pollution is any physical, biological, or chemical change in water quality that has an adverse effect on organisms or that makes water unsuitable for desired uses. Okay? So if it's going to make you sick or not function well, that is polluted water. If all of a sudden the water that you were using, even for recreation or anything like that, if it becomes unsuitable for that, that water is considered polluted, okay? So you can understand if you have a swimming hole or something, or a lake or a stream that you swim in, but it becomes contaminated, it is polluted if you can't swim in there anymore, or if you can't use it the way you want it to. So, and here's a picture of some obvious pollution in a water source. Yeah, question?
So in that case, that means that the water that is considered polluted in food and drinking may not be considered as polluted in recreation.
That's right. Yes, that's right. Yeah, water that's too polluted to drink, you still can maybe boat in it.
Yeah.
Right? Yeah. Their water would be not recommended for swimming at a certain threshold, but not recommended for drinking or consumption at a lower threshold of contamination. So, and we're going to talk exactly about that coming up in this chapter. So, very good. Okay, I do have another video here to show you. So this one, right. All right, so to see that I was paused there for a little bit, I'm not sure what you missed, but point sources of water pollution, factories, sewage treatment plants, non-point sources, runoff from different areas. So fill in those blanks there. Pathogens, microscopic disease causing bacteria, viruses, and parasites arising from the dumping of raw and partially treated sewage. So pathogens, you'll hear that word quite a bit in environmental science and health science a lot. So things that cause disease, basically. Oop, I missed the bottom half there. Yeah. Okay, so plant nutrients and other organic matter. That includes urine and feces from animals, also nitrates, phosphates from fertilizers that run off from feedlots and from different places where these fertilizers are used. Heavy metals include lead, mercury, arsenic, and cadmium, come from industrial sources, acidic mine effluents, and atmospheric deposition. Here's a list of some there. We've talked a lot about heavy metals. And the discussion we had too was that a lot of them are transition metals in the middle of the periodic table there, but not all of them. So any metal, most of them are heavier in the sense that they are not your lightest elements, usually over a weight of 30 or 40 atomic mass units, grams per mole. Other inorganic chemicals, various acids, bases, and salts found from runoff of roads and fields. Okay, so those are types, sources, and effects of water pollutants. Okay, number 5 is sediment. So soil deposits resulting from runoff from agricultural land. They degrade stream banks, from degraded stream banks or road construction. So here you see the river, lots of the banks of the river are starting to erode, and whatever metals or phosphates or whatever are concentrated in the soil there are all of a sudden now in the water system. So sediment, just got two more here. Petrochemicals and other organic chemicals, largely from discharges from chemical manufacturing and other industrial processes. All right, and I think we have one more. Finally, heat. So water pollutants, you don't think of heat as a pollutant, really. It's just energy, but yeah. Heat is sometimes transferred to water from power plants, industrial facilities. This reduces the availability of oxygen for fish, and so it does contaminate the water, even temperature contamination. So let's watch this little video that you'll find on the site. All right, so interesting from that video is not only the rising temperature of water that's released in the environment, but also the reduced temperature of water. So if water is used to give off heat and that cold water is returned, anything that alters the natural temperature gradient of the region. So it's like it's thermal pollution is what it is, but heat, when the water becomes warmer, which is usually the problem, there's less oxygen able to stay dissolved in the water. So gases can be dissolved in liquid, and when the temperature is too high, less oxygen will be able to remain dissolved in the liquid, and it will bubble out as gas, and the fish won't be able to use it. All right, organisms, let's see here. Where are we at here? Alternate though, so no, we have about 7 minutes left. Okay, organisms play several roles related to water pollution. So number one, organisms such as bacteria and parasites can act as pollutants themselves, obviously, and affect human health directly. Okay, so bacteria and parasites. Number two, organisms can take up water pollutants, and these pollutants can become concentrated in the organisms that consume them. So we'll talk a little bit more about this coming up, but organisms, obviously they can make us sick, these bacteria and viruses and parasites, but they also take up water pollutants. So in a sense, they clean up the water a little bit. However, what happens is these little organisms get eaten by bigger organisms, and the bigger the organism, the more contamination that they ingest and have in their tissue. And so when larger predators or humans eat these fish, they're eating something that is a collection point for all of this garbage, all the pollutants. So we'll talk a little bit more about that, something called bioaccumulation and biomagnification of pollutants. But organisms, even the little guys, little parasites, little flies, little things like that can be eaten, and it magnifies the contaminant level. Number three, water pollution can cause an overgrowth of some organisms which have an adverse effect on the environment. So we talked a bit about this already. Phosphates and nitrates can cause excessive algae blooms. So you can have this green, gross algae growing in your freshwater lakes, which cause problems. Even in our water, it was a bit smelly there a couple months ago, remember? That was because of excessive algae blooms in our water source. Bacteria, viruses, and parasites found in water can endanger human health. Water quality is monitored by a series of checks that water quality professionals perform regularly. Water is tested for the presence of a few special bacteria. Coliform bacteria are intestinal bacteria whose presence in a water sample indicates some fecal contamination. So fecal is like your poop, right, or animal poop. So fecal contamination, you have this type of bacteria. E. coli is one that you've heard of. This is quite common, very, very bad for you. But if there's an E. coli contamination in foods that we eat, there's always some sort of recall. I was, what was I? there was a phone call. I had a phone call last night while I'm in bed. There's like a phone call come in. I'm like, who's calling me? And it was like a recall of some food from Costco or something. I'm like, oh, really?
Wait, if you have
It was
already
late at night.
eaten them-
What?
If you have already eaten them, how they
Well, this is the thing. When they notice that there's contamination in a product that's in the store shelves, there are people that have bought them and haven't eaten it yet, right? Or if they're sick, then they know why. Oh, better stop eating that stuff. That's what's making it sick, I guess. You know, so information is important. Yeah, a lot of times. But the thing is, this recall was not on something that I'd purchased. It was just something that they had been selling. I don't know how they got my number. Anyways, Costco. Anyways, so they called and said, hey, if you bought this stuff, there's been a recall. It's bad. So E. coli is, it's one of several coliform bacteria species, but it is the most common and one of the more deadly ones, really. Let's pick this up tomorrow. Okay, we'll complete this tomorrow, talking about testing for bacteria and stuff like that. So that will be video 1 of, looks like it's going to be about 2 here. Mm-hmm.